Right, for 32, we are given a graph, and we have a curve, and we also have 2 points for our line segment. And here's the equation for our curve, and then here's our points for our line segment. And for the first question, it wants us to find the y-coordinate for the point on the curve that has an x-coordinate of 20. So in order to find that value, this is really a good plug-in problem. We know y is equal to, and we're just going to substitute in 20 for our x value. So in this equation that I'm filling in, you can type every bit of this in your calculator exactly as I'm writing it. So you should be able to get an answer very quickly here. So once you have that typed in, and you should get a value of 162. Now, some common mistakes that can happen here, make sure it is just the 20 getting squared there. Sometimes that gets messed up. All right, for the next question, number 33, the length of the curve is longer than the segment FG. About how many coordinate units long is FG? Now for this, we're going to need our distance formula. And so what we have to do with the distance formula, and a lot of people get confused, is it x2 first or x1? Well, really it doesn't matter, because you are subtracting and then you will end up squaring. So as far as which x value comes first, who cares? And then for our second, the same is true with the y's. Now the way I'm writing this is the traditional way that you would see it. And so when we're typing this into our calculator, we are taking the square root of, and then our 2 points that we were given. We have, the first point was 0, 200, and the other point was 200, 0. So when we're typing in and we're subtracting our x values, we're going to have 200 squared plus, and if we subtract our y values, again 200 squared. Now, a common mistake, students think that the square root here cancels out these squares, but you cannot do that because you are adding under the radical. So you need to type all this in your calculators, and you should get something. It's 282 point stuff, and let's see, 0.8, there it is. And so when we round this, we should get answer choice D. Now let's read through question 34. Tram wants to approximate the area underneath the curve, and notice it gives us the same equation again. And let's see, shown shaded in the graph. So he's wanting to approximate the area beneath the curve, so that's the shaded portion that they have for us here. So they're wanting to, he's approximating this area, but now to do that, he's made a triangle from the line segment. So we have a big triangle here that he found the area of. So this big portion out here, FG, and then here, that's what he's found the area of. So the question is, well, is the area that we found with the triangle, is that more or less than the area under that curve? So let's look at F, and initially, hopefully we see that the area under the curve is less, but it also states why it's less. And let's see. Look at the first, we have less than 20,000 units because the curve lies under FG. Well, that sounds right, isn't it? Let's look at our other answer choices before we select F for sure. It says less than 20,000 square units because the curve lies over FG. Well, the curve's not over FG. We see that they cannot be equal, and we see here J and K, that shaded area cannot be greater than the area of the triangle. So our correct answer should be F. Okay, in question 35, a lot of students get lost in such a long problem. Do skim through the problem, but in doing so, make sure you're looking for a formula. And notice down here they're giving us that formula, and that's actually the law of cosines. And this big C out here, that's going to be the given angle. That should be some kind of angle that we have. And that angle C should be directly across from this side C. Now, I am skipping through reading the problem because that is such a long problem. And notice, based on the information, it looks like we're just plugging in to that formula. That's really all it's looking at. So, let's see, in question A, does that look like we've plugged into this ginormous formula up here? Well, no. Well, what about B? Because notice A and B, those are sides of the triangle, and here's the sides that were given. So, yeah, B, C, D, and E all look like they've started the formula correctly. Now, notice the next part of this formula has to have a minus sign. So, notice C does not have that minus sign. And notice, let's see, D or E does not. So now I've narrowed my choices, and I haven't even read the problem. I've narrowed my choices down to B and D. And notice again, C should be the angle that's between the two given sides, which is 5. So which one has that given angle? It's going to be answer choice B. And honestly, I did not have to know anything about the law of cosines so much. I did not really need to memorize the formula. Just look and see, did they plug into that formula correctly? Okay, number 36. Which of the following equations expresses C in terms of A? And so, gosh, let's see. We know A cubed equals B. So A cubed equals B. And I know B squared equals C. Now I want C in terms of A, so really I just want C to equal something about A. Something about it, we don't know what yet. Okay, so let's see. Well, I know A cubed equals B and B squared equals C. So it looks like if A cubed equals B, if I take this A cubed and I substitute it in down here for B, I would have C equaling something about A. So let's see. If I do that, that is B squared. So that squared has to still be there. But I'm replacing B with A cubed. Oh, this isn't wanting to write cube. Let's see if we can make it write it again. There we go. Nope. And now let's see, what do we have that looks something like that? Well, we have to get rid, let's see, H, J, and K. And so we have to remember, well, do I add these exponents or will I multiply them? Well, if you have an exponent and it's raised to another exponent, you always multiply those. So 2 times 3 is 6, so the correct answer is F. Okay, moving on to 37, we have 2 different equations that we need to set up. And notice we're spending 2 days of travel here. So I have a 2-day, and notice one of these, the seahorse, so I'm going to abbreviate seahorse. And for that, I have to pay $50 per day, and I'm going for 2 days. So that's going to be $100. Plus my mileage. Well, what am I going per day? It's 0.25 miles per day. So let's see, or 0.25 miles. So 0.25 miles. And let's see, we have ocean blue. Kind of the same situation here. We're $50 a day. And we have $60 per day. So that's going to be, let's see, 2 times 160. So 120 plus how much per mile? 0.2 per mile. And let's see. and he needs to spend, he has $255 to spend. And he wants to know which company, if either, allows him to travel more miles for the 2 days, and how many more miles is he allowed to travel. So this is the total amount he spent here and here. So let's set both equations. We're going to set those equal to how much he's allowed to spend. Let's see, that's going to be 0.25 m equals 255. And we need to solve that for m. And if we subtract 100 over and then divide by 0.25, and I'm going to go ahead and write that out, 0.25 m equals 155, and we divide both sides by 0.25. So here m is going to be, I don't remember, let me look and see. M is going to be 620. And then for the other equation, we're going to do the same thing. We're going to say 120 plus 0.2 m equals 255. That's how much he has to spend. And solving this equation, subtracting 120 over, so I have 0.2 m equals, and if I subtract there, I get 135. Dividing, so m from the ocean blue is 675. And so notice that he's going to get more miles from the ocean blue. And then, so that's going to eliminate answer choice A, D, and E. And then by how much? Well, what's the difference in these two? It looks like the difference is 55. So the correct answer is B. Okay, moving on. Here we need to find the area of a parallelogram. And the area of a parallelogram is going to be area equals your base times your height. And a lot of times people get lost in base and height. Just look at your ordered pairs that you're given. Your base, which is the distance from here to here, well, that's 10 units. And then what about your height? How high is this? That's going to be your y. So the height is 6. So the area is 6 times 10, which is 60. So that's answer choice G. All right, so for 39, it says for every pair of natural numbers n and m, to which of the following sets must m plus n belong to? So most everybody, we're not used to seeing natural numbers, and we're not real sure what natural numbers might be. Natural numbers would be what you can count on your hands and feet. That's one way to put it. If we looked at a number line, let's say -3, -2, and let's draw this out all the way over to +3. Get a good range here. If we talk about natural numbers would start at 1 and trek to the right. So this would be your natural numbers. And then if you were asked something about whole numbers, well, whole numbers will be all your natural numbers, but then it would include 0. So that's going to be your whole numbers. And then if you want to include everything from left and right, then we're going to call that, from left to right, we're going to call that integers. And then if you really wanted to expand this and say, well, what about fractions and decimals and including integers, that's going to be your rational numbers. So there's a little quick idea of all the different sets of numbers. Now we do have irrational and complex, but this is usually what you're asked. Irrational numbers, again, is all of the integers and fractions. So that way you know if you're asked, that's what it's looking for. So if we have a natural number, notice natural numbers, well, that's in the set of natural numbers, yes. It's also in the set of integers. It is a rational number. a real number, yeah, and a complex number. So it really fits all of those. So that's going to be answer choice E. Natural numbers are the most basic numbers we would have to work with. Number 40 is a great calculator problem, and I encourage you to do this one on the calculator to save yourself some time. You have a perfect square that has exactly 4 digits. So it's saying, well, the square root has to have how many digits? Well, if you take the square root, let's start at the bottom end. The square root of 1,000, you're going to get roughly 31.6. And if you take the square root of 999, then that's going to be roughly 99.95 and so on. So notice that in between there, the lowest end is 2 digits and the highest end is 2 digits. So it makes sense that G is going to be the correct answer there. Okay, moving on. Now number 41. 41 is an expected value problem, and they look very intimidating, but expected value problems always follow the same exact pattern, and they're not just terrible. You have 80 rooms, and you're given this probability chart, probability distribution. To the nearest whole number, what is the expected number of rooms that will be occupied on any day during the coming summer season? So the first thing we really need to do is find, well, what is that probability? What is it going to be? And in order to do that, you need to multiply these values. So you need to multiply 0.6 times 0.20, and that's going to generate 0.12. And then you need to multiply 0.7 times 0.4, and that's going to generate 0.28. And again, these values, I'm just multiplying these that are across from each other. So the next value would be 0.8 times 0.3, so that's going to be 0.24. And 0.9 times 0.10, that's going to give me 0.09. Now, to find out what is that total probability there, you're just going to add all of these up. And if you add this, the sum of those probabilities is 0.73. And now we have that probability. Now we need to know, well, how many rooms were we told we would occupy? Well, we're going to occupy, we have up to 80. So 73% of 80, or 0.73 times 80, that's going to give us 58.4. So the correct answer here would be C. For number 42, we're multiplying matrices. And matrices, you want to multiply element to element, and that's not necessarily how you would multiply these. You do need to check the dimensions, and the dimensions for all matrices, you look for a row by column. So our row by column means that we are going to say number of items going this direction by the number of items going this direction. So for this particular problem, we have 3 items going left to right, but we only have 1 column, so that's a 3 by 1. And then let's look at this next one. We only have 1 item going left to right, but then for our columns, we actually have 3, so that's a 1 by 3. And then with the product of your matrices, you really can tell the dimensions of your answer, and that's going to help eliminate some of your answer choices. So these numbers have to match for us to be able to perform matrix multiplication. And then actually these leftover dimensions out here, that's the dimensions of my answer. I need 3 rows and 3 columns. So notice that will very quickly eliminate 3 of our answer choices by knowing that. Now, as far as the actual elements, well, notice when we multiply, we are going to take this row which just contains A, and I need to multiply it to every element in our second matrix. So we are actually, and I'm going to erase some of what I have up here. So let's see, if I erase this, I'm going to remove all of this, and let's look at what we get when we do some of this multiplication here. So what I'm going to do is take A, and I'll multiply it to each part in the second. So I'm going to take A, and I'm going to multiply it here, here, and here. And that's going to make up my first row. So my first row in my answer should be A, 0, and negative A. Most of the time, that's enough information to be able to pick out your answer choice. And in this case, I believe it is. If we look at our answer choices, notice that answer choice F is the only one that contains those elements. So here for 42, the right answer is F. Okay, moving on to number 43. Notice that with our angles, we want to know what is the degree measure of the smaller of the two. Well, the smaller of the two looks like it's going to be 2x, but we need to figure out, well, what in the world is x? So I know if I look at how many degrees are from here to here, that's a total of 180. So I really can add 4x plus 6 plus 2x, and all of that should give me 180 degrees. So I'm going to have 6x plus 6, we collect our like terms, equals 180. So 6x equals 174. And we need to divide both sides by 6. And so x is going to be 29. Now, notice they give you that as an answer choice, and they're just being tricky because you're looking for the smaller of the two angles. Well, the smaller angle is 2 times x. So 2 times 29, well, 2 times 29 is going to give us 58. So they were trying to trick us here. The right answer is answer choice D. So don't be fooled by them. All right, and for 44, this is a traditional problem that you will see. And let's see, what are they? You've got an expression, and with that expression, they add certain values, don't they? So let's go ahead, and I'm just going to rewrite this above expression using the values that they tell us. So let's see. We are going to say, well, originally A is equal to all of this. So let's see what the new A is going to be equal to. So I have 2 times B, but B is going to be decreased by 1. And the value of C is increased by 2. So I have plus 3 times C, but in place of C, I'm going to put C plus 2. Because C is increased by 2. And we still have our minus 5 here. So the difference that we're looking for is really when we do our distributive property, we're going to have a negative 2 here. And out here we're going to have a positive 6. So if we combine these two, we're seeing we have a difference of positive 4. So A would be increased by 4. So the correct answer choice is F. For number 45, Shmia, I suppose, will mix 1 fluid ounce of fertilizer in water for every 40 square feet of soil. So we can go ahead and set up one proportion, and we're just going to do a lot of conversions here. And notice from the answer choices, they did not multiply out any of this, so I probably would not either. So I know starting out I have 1 ounce. So we're going to do 1 ounce per 40 square feet. Now, notice that as I'm going to skim through the problem, and it says, which of the following expressions give the number of gallons of fertilizer? And let's see, and it's really in water for 0.5 acres. So really, whenever I finish multiplying out these conversions, and I'm just going to put a bunch of lines here, I'm going to want that end product to be number of gallons per acre from the way the problem's reading. So gallons per acre. And I suggest doing this just because you can use those units to guide you through the problem. And notice here they're giving us a note that for every 1 acre we have 43,560 square feet. And I would use that first since it's here first. So I know I'm going to have 43,560 square feet, and that's per 1 acre. And so notice I'm already getting these units to line up, and I do want those feet squared to cancel. And looking at what I have so far, how many answer choices could I go ahead and cancel? Because again, I'm looking for gallons per acre, right? So let's see, it looks like I can go ahead and eliminate A. It looks like I can eliminate B. It looks like, let's see, I can't get rid of C, and I can't get rid of D or E. So let's see, for 1 ounce, well, I know, let's see, for 128 fluid ounces, I have 1 gallon. So I know 128 fluid ounces for 1 gallon. So that's going to allow me to remove those ounces. And notice here with my units, I have 1 gallon. This is what I have left as far as units. 1 gallon for 1 acre, which is what I needed. So let's see, I have 43,560, and I have gallons in the numerator. In the denominator, I have 40 times 1 times 128, and that is per acre. And again, notice that it's a 1-to-1, but I only need half of an acre, so I need to multiply this by 0.5. I only need half of this ratio. So that looks like we are going to end up with answer choice C. A restaurant has 10 booths that will seat up to 4 people each. If 20 people are seated in booths and no booths are empty, what is the greatest possible number of booths that can be filled with 4 people? So we have 10 booths, we have 20 people. And one way to figure this out is I just drew this out. If you don't see initially what to do, so here, so that's going to be what, 2, 4, 6, 8, 10 booths. And you know no booths are empty, so you know there's going to be the first 10 essentially are taken up. So you have really 10 people left, and you need to see what's the greatest possible number. So I really, 4 people, I need to add 3 booths, 3 more people to each booth, and notice that's going to give me 3 1/3. So really the maximum number of booths is going to be 3. Okay, looking at 47, and usually this probability notation really disturbs people. Just glancing through, some important details that you need would be that A and B are independent events. It means what happens with A does not interfere with what happens with B. And you notice the notation, it wants to know, well, what is the probability that events A and B will occur? When you see the word and, you need to remember that that implies multiply. And is multiply. If you saw the word or, that would mean, well, that looks absolutely terrible. Let's see if we can write that better. The word or is going to imply that you add. Add means or, and means multiply. So glancing through here, well, the only place I see some kind of multiplication is here, but this would imply that probability of A plus the probability of B minus the probability of A and B. So that's going to be if these were not independent. This is where they might be dependent on each other. It's where some of the values might overlap. So the only other possible answer choice would be probability of A and probability of B, which is answer choice D. Okay, on number 48, let's see. We need to know, well, what is the value of cosine of theta? And notice that's the big angle on the outside, but we can use inside here, this would be called theta prime, and it's a reference angle. And it's a reference angle because we can refer to that value to really get this value out here. Now we can connect these, and we actually have what's called a 3, 4, 5 right triangle. If these two sides are 3 and 4, this other side will always be 5. Or if you don't remember that, you can do the Pythagorean Theorem. That missing side is going to be the square root of 4 squared plus 3 squared. And yes, I ignored the signs because you are squaring those. That's going to give me the square root of 16 plus 9, which is 25. And so we see that it will always generate 5 for us. Now, if we do cosine, we are going to have to remember SOHCAHTOA. So sine is going to be your opposite side over hypotenuse. Cosine is going to be your adjacent side over hypotenuse. And tangent is going to be your your opposite over adjacent, So from this angle's point of view, 4 would be your adjacent, 3 would be the opposite, and 5 would be your hypotenuse. So if I wanted cosine, I need adjacent over hypotenuse. So that means I need 4 over, and our hypotenuse is 5. Now notice we do have some signs here, and you can attach these signs to help us. But here, fourth quadrant, cosine's always positive. And so we see that we're going to get answer choice J. Okay, number 49. Which of the following expressions, if any, are equal for all real numbers? Now, this one can be a little bit tricky. One thing for sure, students like to think that 2 and 3 are the same. They are not. They are opposites. 2 and 3 are not the same. So if we have any that says 2 and 3, well, we can eliminate here C, and I can eliminate D. Now, let's see. For the first one, a lot of times we want to say the answer for that is just X, but really it's the absolute value of X, because no matter what value I care to plug in, no matter what real value I choose to plug in, that's always going to be just an X, or the absolute value of that X. So here 1 and 2 are the same, so that's going to be answer choice A. Okay, in problem 50 in the figure below, A, C, F, and D are all collinear, which means they're all going to be on the same line. And B, C, and E are collinear. And the angles A, E, and F are all right angles as marked. Which of the following statements is not justifiable from the given information? So I would just go through all of our answer choices and see. So let's start with answer choice F. And answer choice F says AB, so the segment AB, is parallel to EF. Well, if you notice, AB is saying AB is parallel to EF. Well, notice that they are both perpendicular to the same line. So if that's the case, then they do need to be parallel. So that one is correct. So again, we're looking for which one is not justifiable. Let's look at G. DE is perpendicular to BE. Well, again, notice how it is written the way this is here. Well, yeah, that has to be true, so that one can't be it. Angle ACB, so we have ACB, this angle here is congruent to FCB. Well, yeah, those are vertical angles, so they are congruent there. So that one's correct because those are vertical angles. J, triangle BAC is similar to triangle EFC. So it looks like, let's see, EFC, we are sharing two angles because angle A is 90 degrees. Here at EFC is also 90, and then earlier we have these two angles here that are congruent because they're vertical angles. So by the angle postulate, then that one is also true. So the only thing left that we cannot conclude by process of elimination would have to be K. CE is congruent to ED. So let's see, CE is congruent to ED. Well, there's really not enough information. We don't know the length of that side here. This side here is the same as this one over here. So that's a good choice. All right, in 51, we are asked to find the perimeter of the figure. And let's see, we're missing a few sides, and that's normally, we'll be missing a few sides here. Let's see, this side length over here would be 1. This is the same length as this side over here, so that's going to be 3. And we're missing this little portion here, and that's usually where people miss this. That little portion there, the whole thing is 4, and we know this much is 3, then this little part here has to be 1. So now we're going to add up all of these sides, so 3, 3. And then, goodness, 2, 3, 4, and 4. So it looks like that's going to give us 6 plus 8, which is going to be 14. So answer choice D. Okay, in 52, we have triangle ABC, and it has the given vertices. And notice we're given certain values for each point. Point C can be moved along a certain line, with points A and B remaining stationary. So point C is going to be moved. Well, let's see. If point C is going to be moved, we want to move this so that the area of ABC, the area of this triangle, is not going to be changed, but I want to move point C. And it wants to know, well, what is the slope of that line? Well, let's see. We've got points 0, 6. And we have points, let's see, 8, 2. And then we have negative 3, 2. Now, I want to be able to move this so that the area of the triangle will not change. So let's think about this. Area is 1/2 base times your height. Well, the base is going to be from C to A, and my height is going to be, well, is from here to here. So I want to move point C so that these values are not changing. So let's see, I don't want the height of the triangle to change, or the area to change. The height might change and the base can change, but the area. So it looks like here, if I extend a line through AC, I wish I would make that a little bit straighter. If I extend a line through there and I extend this line here, I know A and B are staying stationary, but if I move C along this line here, those are going to be, as long as those are parallel, the values of the height and the base, or the area, is not going to change. So and that's going to be because the distance between B and C and A are going to be, those distances are not going to change the area. So we need to find is the slope of that line, which at the end of the day is going to be the slope using those 2 points. So the slope is going to be y2 minus y1 over x2 minus x1. And so we're going to subtract the 2 y values. So I'm going to say 2 minus 6, so negative 4, over 8 minus 0, which is 8. So we're going to get negative 1/2. So that's going to be answer choice F. And in my opinion, that's a pretty tricky problem there. But as long as we keep our distance fixed between the two, which is the definition of parallel lines, they have that fixed distance between each other. They never cross each other. So there you go. All right, moving on to 53. On his first day as a telemarketer, Marshall made 24 calls, and his goal is to make 5 more calls on each successive day than he had made on the day before. If Marshall met but did not exceed his goal, how many calls did he make in all after spending exactly 20 days making calls as a telemarketer? So, you need a couple of formulas here. And one formula that you need is going to be the sum formula, because it wants to know how many calls did he make. Well, whenever you have something like this where you have an arithmetic sequence, the sum of n objects is going to be those n objects, however many you have, divided by 2 times, and it's going to be the first number, first amount, plus your very last amount. That's how we're going to add these up. But then I need to know a way to figure out, well, what was that very last amount? That last term, to find that out, is going to be your first term plus the number of terms minus 1 times how is this changing each day. So the first thing we need to do is probably find that last term, because we know the first term because we know on the first day he made 24 calls. And we know we're spending 20 days. So really I need to know, well, what is that 20th term? Well, it's going to be 24 plus 19. That's going to be n minus 1, or 19 times, well, how is it changing each day? It's changing by 5. If we type all that mess in our calculators, we're going to get 119. So now we need to see, well, how many total did we really have? Well, the sum is going to be our total number, which was 20, over 2, times the sum of the first term, which was 24, plus our very last, which was 119. And if we do all of that, it looks like we're going to end up with 1,430. So that's going to be answer choice D. Okay, for 54, which of the following is the graph of the function f of x below? And this is a piecewise function. And a lot of people see this and they get very intimidated by it. Please don't. What we're going to do is isolate parts of this problem. So I'm going to take that very first part, if I can get this pen to work, and let's just focus on this portion right here. So again, sorry, technical difficulties here. Let's work on that part. So notice I have x squared minus 2. If you see x squared, that means that I have a U shape. If it's x squared, it has to be a U shape. Now, where do I have that U shape starting at? Well, you need to plug in and see. So let's plug in 1 in over here and let's see. So 1 squared minus 2, that's at -1. So I found for this U part, it's going to start at the point 1, -1. So let's go through our answer choices and see. We have a U shape, and this U is turned upward, so automatically, and I know that because x squared is positive, so I know it can't be F. I know it can't be J because I'm not starting at the point 1, -1. And again, it can't be G. And oh my, look, it can't even be H. It's not at 1, -1. The only possible answer is K. And I did not have to look at anything else. So there, very quickly, if I know my highest exponent is a square, it's a U shape. And again, I would plug in to see, well, where does this need to start? So that's how we work through that one. Not too terrible, I hope. Now looking at number 15, this is a formula. It's a permutations formula. Right, in number 55, the formula for permutations of 15 objects taken, or in objects, let's just say in general, taking R at a time, be in permutations, and let's see. So, let's see, that's going to be n factorial over the formula, I believe it's n minus r factorial. And so n and r are the objects that were given. Now, if it had said combinations, you would still have n combinations of r, but that formula is a little different. It's n factorial over, and you still have the n minus r factorial, but it's also times r factorial. And again, that would have been if they would have given you combinations. So n is going to be, in this problem, n is going to be 15 and r is going to be 5. So really, for this particular problem, if you just knew what the formula looked like, well, this then is going to be combinations. And so the only one left that looks remotely like the formula itself is answer choice D. Okay, moving on. For 56, this is really a heavy algebra problem. For all x's being greater than 0, which of the following expressions would be equivalent to this? Now, with I, a lot of times students like to try to cancel that, and you end up with a mess. What we have to do here is do some rationalizing. And so we have I in the numerator over the square root of x minus I. So what we have to do is multiply the top and the bottom because we can't have i's in the denominators. So the square root of x plus I. That's what we need to multiply top and bottom by. And when we do this, we need to multiply by using the distributive property here. And so I get I square root of x, and then I times I is I squared, but then I squared is -1. So I'm going to go ahead and write -1 here over, and then in the denominator, the square root of x times the square root of x just leaves us with x. And then here in this situation, these terms should always cancel each other out, the outer and inner terms. And then we have minus I squared again. Well, minus I squared is going to be minus a -1, which is going to give us plus a positive or +1. So which of the following should be equivalent? Well, it looks like it's going to be K. k should be our equivalent. Moving on to 57 with vector notation. Notice here with this notation, we're going to have to change up a few things. Well, we need to figure out, well, what is the coordinates for A and B? So the coordinates for A, if we count over, A is going to be the coordinates. Let's see, if we do some counting, A should be -6, -2. And then B is going to be the coordinates of 3, 4. And if we write this over in the component form, well, it's going to be 3 minus -6, which is going to be 9. And then 4 minus a -2, which is going to be 6. And so we have this in our component form. We also need to do the same thing for CD. So here we need to find, well, what is C going to be? If we count off C, we have 4, -2. And then if we count off D, D is going to be 4, 3. And again, we need to go to that component form. So 4 minus 4, that's going to be 0. And 3 minus a -2 is going to be 5. And then it wants us to add these two together. So we need to go through now and do some adding and put this over in these forms here. And so let's see, 9 plus 0. So that's going to be our 9i. So that's going to get rid of those. And then 6 plus 5 is going to give us our 11j. So that's going to be answer choice E. Hey, number 58 is another one of those problems that looks very intimidating just because of the sheer length of the problem that you're given. Do skim through the problem and notice what each of the variables would be in our formula that we're given. And so I just skimmed through and I see that T must be time, L is going to be the length in feet of the string. Now let's get down to the very meat of the problem here. If the time required for a complete swing of pendulum 1 is triple the time it is required to complete the swing of pendulum 2, the length of pendulum 1 string is how many times the length of pendulum 2. So really we have two equations here we can set up, because we're going to set the time equal to each other. So one of these, I'm going to have 2 pi times the square root of L over 32. And that's going to be equal to, and then the next one, well, it's 3 times. So we're going to say 3 times 2 pi times the square root of L over 32. So notice here we have these two equations, and we really need to solve for L. So here, let's see, gosh, let's see, we've got 2 pi square root of L over 32 equals 6 pi, and let's see, times the square root of L over 32. And let's see, these 2 pi's, I would cancel that out, leaving 3. So I have the square root of L over 32. Oh, that didn't write so great. Equals 3 times the square root of L over 32. And again, we need to solve for L, so we need to square both sides, wouldn't we? And notice automatically, if I do that, notice what I'm going to get. 3 squared, so that's going to give me 9. So how many times the length of how many times the length of pendulum 2 string? Well, it's going to have to be 9. So that problem, it wasn't just terrible. You could skim through and just grab some important parts there. All right, and number 59. Log base A of x is s, and log base A of y is t. Now this is going to hinge on us remembering some of our logarithm properties, and most people won't know. First thing that we need to look for is anytime we have an exponent, that exponent is going to be moved down to the front. So it's really 2 times log base a of xy. Well, automatically that can eliminate a couple of answer choices. We know it's not going to be E, and we know not B and C. So we have to decide, well, is it going to be multiplying or adding? And it actually becomes an adding problem because with our logarithm properties, that's log base A of x plus log base A of y. And notice if we substitute in our s and t, that's going to be 2 times s plus t, so that's going to be answer choice A. Okay, moving on to our last problem. Jennifer's best long jump distance increased by 10% from 1990 to 1991, and then by 20% from 91 to 92. By what percent did her best long jump increase from 90 to 92? And please don't just try to add those two percentages. People do that all the time. They want to say 10 plus 20, 30. Oh, look, it's answer choice G, and you miss it. So be careful with that. We need to calculate, well, what was the difference for each year? Well, let's see. She increased her long jump by 10% from 1990. So let's think about this. So from 1990 to 1991, she increased by 20%. So that means all that she was originally plus 10%. So 1.10 times her distance D. And then from 91 to 92, she increased by 20%. So from 1991 to 1992, she increased 20%. So that's 1.2 times what she already had a distance of, which was 1.10 D. And so if we multiply these two values, we're going to get 1.32 times D. So she really increased by 32%. So that's going to be answer choice F.